Homework 1.6, other types of equations, video number 2. Homework due Saturday, May 16th, 11:59 p.m. In the previous video, we solved one polynomial equation by using the same technique as with quadratic equations. Get the equation equal to 0 if it's not equal to 0 already. Factor it as much as we can. Set each factor equal to 0 and then solve each of the smaller equations. In this example, we're going to do another one. And by the way, the examples that I'm using are similar to ones in the homework. So for example, this one I believe was my version of number 3 on the homework. Yours will probably have the same structure, but some different numbers. At the conclusion of this video, you should go to homework 1.6 and try questions 1, 2, 3, and 4. All right, so let's solve this one. First move, get it equal to 0, and it's not. So we have a decision to make. Do we want to move everything to the right and make the 0 on the left, or move everything to the left and make the 0 show up on the right? Both are correct, but when you're making a decision like this, I try to make the decision that keeps the highest power negative. It just makes factoring a little bit more tolerable. Since the highest power is currently positive, I don't want to move it, so it's going to stay on the left side, and so everything's going to come over to the left side. Technically, the move to get rid of the things on the right would be to subtract both of them from both sides since they're both positive. But visually, you can just imagine picking these up, moving them to the other side, and changing their signs. And if we did that, we would have x to the third power, which didn't move, so it didn't change signs, plus 2x to the second power, which didn't move, and so it didn't change signs, minus 81x, which did move to the other side, and so it did change signs, and minus 162, which did move to the other side of the equal sign, so it did change signs, is equal to 0. Okay, so we just moved some things around and got it equal to 0. Next move, factor. If you're not sure what factoring technique to try, please go to the second module and watch video 2. Because this has 4 terms, we're going to attempt to factor it by grouping. I think I mentioned this in the video 2 in the second module, but if you're going to be asked to factor something and it has 4 terms, right now it's probably going to be a grouping problem. Later that will change, but for now, a grouping problem. And remember, a grouping problem works by taking a polynomial and splitting it into 2 equal-sized groups. We don't have a choice, it's got to be 2 terms and 2 terms. And then factoring out a greatest common factor from each group. From the left group, the leading coefficient here is 1, so the only number that will divide into both of these, or at least the only positive number, is 1, so we won't mess with that. But they do have some x's in common, and when you're factoring out a variable, you always use the lesser of the 2 powers, or the least power among them. In this case, that would be x to the second. So each of these terms is going to give up 2 of its x's. X to the third, take away 2 of its x's, leaves 1x. The 2x squared, if we take away its x squared, it's just left with a plus 2. On the second group, I got to factor out a GCF as well. 2 things. 2. Number 1, if you're factoring a polynomial by grouping, then on the second group, you should always include the sign right after the split to tell you the type of GCF to take out. So we're going to take out a negative GCF in the second group. Secondly, what is the greatest common factor of 81 and 162? It may not be obvious, but I want to remind you, like I did in the second video in the second module, that if you're factoring by grouping, and you're pretty sure it's a factoring by grouping problem, you already know what the second parentheses has to be. Because in order for grouping to work, these must match. So sometimes you can kind of assume you know what that second parenthesis is going to be, and then use that as a guide to figure out the GCF. So for example, whatever I take off of the first term needs to leave behind just an x. Well, that would mean I would have to factor off the entire 81. Now, if you're going to kind of backdoor your way into the second GCF, you really should go ahead and distribute to make sure that it's correct. Negative 81 times x, yeah, that part's right. But guess what negative 81 times 2 is? Negative 162. So sometimes you can, it's not really cheating, but it's kind of knowing in advance what's supposed to happen when you're doing the second half of a grouping problem. But if you take the GCF out of each half, and the parentheses match, that's a sign you're on the right track, because your next move is to factor them out collectively as a gigantic GCF. So the x plus 2 gets factored out, and all of the remaining parts literally make up the other factor. X squared minus 81 equals 0. Okay, good start. And if you're on your game, you might go, wait, we can factor this again. Excellent. That's another difference of squares. By the way, if you didn't factor it, all's not lost. You could put this equal to 0 and solve it using square roots, because it is still a quadratic equation. But x squared minus 81 will factor into x minus 9 and x plus 9. And now that it's completely factored, you can tell because there's no powers left, we can just set each factor equal to 0. I would like you to get to the point where you can actually bypass writing the line that I just wrote. Thinking it and then saying, if I solve that, if I solved x plus 2 equals 0, I would get x equals negative 2. If I solved x minus 9 equals 0, I would get x equals 9. And if I solved x plus 9 equals 0, I would get x equals negative 9. So if you can go immediately from factors to solutions, good, because that move is not going away. Later on in chapter 3, it will be all up in a lot of problems. So looking for places to, save a little bit of time is a good thing. All right, so at this point, you might want to get into the homework from 1.6 and try questions 1, 2, 3, and 4.